Okay, this is a video lesson about products and quotients of functions, 10.2 in the textbook. So we're starting off by looking at two linear functions. So down here we have f of x in red and g of x in blue. They are shown below in our graph, and we're going to complete the table of values for those two functions. And then for p of x, which is a product function, we're multiplying these two together. So we just take a minute and fill this out. When x is -4, it looks like g of x is -3 down here, and f of x is -6. So f of x was -6, g of x was -3. And then when it's -2, it looks like we have -4 and -2. When x is 0, right here, looks like we have -2 for the red function and -1 for the blue one. So that's these points here and here. I'm just filling this in. So 0, 0, and then over here at 4, there's our two values, so 2 and 1. And then lastly, out here at 6, we have, looks like 4 and 2. Okay. So to determine the product function p of x, we're just going to multiply the two values here. So when x is -4, -6 times -3 gives me +18. So I might choose a different color to do this. And so when x is -4, we are way up here at 18. So there's our first point for our product function. -4 times -2 is going to be 8. So when x is -2, our function is equal to 8, so that's there. -2 times -1 for our third point is +2. So 0 and 2 is right there. Next, 0 times 0, well, that stays 0. So this is that point. 2 times 1, 2. Well, there's that guy. When x is equal to 4. Next, at 6, 4 times 2 is 8. So when x is 6, function is at 8, right there. So if I connect those points, we can see that our product function is a parabola. All right, so one way we can determine the product function, this p of x in this case, is by multiplying the values of f of x by g of x to obtain our new values. And so that's one of the skills, is doing that from a table of values. And down here, we're going to do it using the equations of f of x and g of x. So f of x is this line right here, and you can see that its y-intercept is at -2. So I know that f of x is going to be something or other x, the slope, take away 2. And if I look at the slope of this line, it looks like I've gone up 2 and over 2. Notice the scale on the x-axis is a little bit different than on the y. Here I'm going up by like half, and then 1, and then 1.5, and then 2. So it looks like I've gone over 4, but it's really only 2 units. So I know that this is 1x minus 2. And then if I turn my attention to the blue line, g of x, its y-intercept is, let's make some room here. Its y-intercept is at -1. And its slope, this one I go up 1 and over 2, so it's 1/2 x minus 1. So just like we multiplied the values in the table of values up here to get our composite, our product function, not composite, our product function, p of x can also be obtained, the equation of p of x can be obtained by multiplying f of x, which is x minus 2, times g of x, which is 1/2 x minus 1. So now I'm just going to FOIL this out, right? Multiply two binomials. So I have 1/2 x squared when I multiply here, minus x when I multiply there. Negative 2 times 1/2 x is going to be another negative x. And negative 2 times negative 1 is positive 2. So p of x equals 1/2 x squared minus 2x's plus 2, which hopefully we can see is the equation of a parabola in the form ax squared plus bx plus c. C being our constant, our y-intercept. And that's what we see in the graph up here. That was this point right there. And one other thing I wanted to show you about this is I've written p of x being f of x times g of x just together like that. And so that's one way you can write it. But we can also write a product function as f times g of x. And that means the same thing as f of x times g of x. So these are different notations meaning the same thing. So you might see this, it's a filled in dot, that means multiplication. Okay. And one other question about those graphs that we just did. What's the relationship between the x-intercepts of the graph? Well, they're the same. They're right there. So the x-intercepts are the same. So I want to make note of that. And indicate the domain and range, we should say, of p of x, of the product function. So, okay. So indicate the domain and range of p of x. So our domain, the domain is x is an element of real numbers. And we saw the other day with the sum and difference functions was that the domain is common among the two. So if I'm looking at g of x and f of x, for these two lines here and here, their domain is x is an element of real numbers. So my product function will have the same domain. So common to f of x and g of x. However, with the range, we do have to look at the graph again. And so if we look back at our graph that we've drawn here, or one that's in the calculator, another question, you can see that y has to be greater than, or equal to 0. So our lowest point is right here. So we want to find that vertex, and that's going to help us, in this case anyways, to write the range. So y such that y is greater than or equal to 0, and y is an element of the real numbers. And this again comes from the graph. All right, so that is a product function. Let's look now at this one, which I've got the graphs of f of x.
What's up, Dave, and welcome to your...
Okay, so here we're looking at two graphs, the function f of x, which is x squared plus x minus 6, so that is the blue parabola over here, that's f of x. G of x, 2x plus 6, that is the red line on our graph. Complete a table of values, then determine h of x, which now is going to be a quotient function. So just like before, we're going to have a table of values to fill in for these functions. And I'll just do that quickly, and then we'll see the next step. So here, -2, f of x is -4, g is 2, -6, and 4, -6, and 6. So again, I'm just reading them off of the graph. So the one I just did, 0, -6 down here, +6 up there. That's all I'm doing. Just filling this in quickly to save us some time. And this is 8, 0, and 10. And then the domain for f of x for our parabola is x is an element of the real numbers. And for the red line, g of x, same thing. So just pop that in there. All right. And for the range, I had to find this point down here, so I used my calculator to find the minimum, which turned out to be at -6¼ and then y is an element of real numbers. Trying to squish that into that little box. There you go. And for our line, y, such that y is an element of real numbers. All right, so before we multiply our two values to get the product, here we're talking about a quotient function, and we're going to be dividing f of x by g of x. So this is x squared plus x minus 6 over 2x plus 6. So that's our function. So that means I'm going to take the f of x value and divide by the g of x value. So -4 over regular 2, I guess, is -2. So that's my first value. When x is -2, the y value is also -2. So that's this point right here. -6 over 4 is -3 over 2, or if you prefer, -1.5. So that's going to be right there. And -6 divided by 6 is -1. So when x is 0, it's right here at -1. And then -4 divided by 8, well, that's -1/2. So hopefully you can see the pattern here that every time I go over 1, I'm going up 1/2, right? Over 1, up 1/2, over 1, up 1/2, and so on. So just going to delete that, and then draw in my line. Here, the last bit though, 0 divided by 10 is 0. There we go. So there's our line. With one condition here, one thing to think about that's a little bit different. Because I'm dividing, and now I have a 2x plus 6 in the denominator, that means I'm going to have a non-permissible value. So if I think, what value can I not put in there for x? Well, x cannot equal -3. Because if I put in -3, I'd get 2 times -3, which would be -6, plus this 6, I'd be dividing by 0, not allowed. So here, I actually end up with a little hole in the graph, where I have an open circle. So this is going to affect the domain now. So that's the one sort of difference between the product one and the quotient one, is that I have to consider, are there any NPVs? Do I have a variable in the denominator in this case? And that's going to affect my domain. So now the domain for this is x cannot equal -3. And that's that little hole, that little opening right there in the line. But otherwise, x is an element of real numbers. And then we want to consider what the y value is for that point. And it is at -2.5. If I follow my pattern, this one's at -2. I'm going up and over, up a half over 1. So if I go down a half, I'm at -2.5. So here, that point is at -3, -2.5. So this is going to affect the range. And then otherwise y is an element of the real numbers. Okay. So that's one thing to consider, is the domain in the quotient. Think about our NPV and think about the corresponding y value. That's going to affect the range. All right. So our conclusion. How do you find the domain and range of a product or quotient function? So the domain is common to the two functions. The two original functions that we're either multiplying or dividing. And then in a quotient function, look for an NPV. And if you use, if I put in, sorry, let's go back here. If I put this function as it is into my calculator, and then I look at the table of values, I'll see an error spot in the table of values for this function at the point where x equals -3. It will not let x equal -3. And similarly for y, it will not be equal to -2.5. So you can try that by looking at the table of values in your calculator. And then the range. The range we use the graph to determine. And by that, really, we mean you were using a calculator often. All right, so as I said before, when we're given two functions, f of x and g of x, the product function, I multiply them and it looks like that, or a filled in dot like that, or like this. So we've got a couple of ways to do it, and the quotient looks either like this, whoops, or like that. So that's our notation. This, or, sorry, I guess I should add, or f times g of x. So there's another way. All right, so right now we're going to try doing some algebra. So what I'd like you to do is maybe we'll pause at this point, and I want you to write out the product function. Here's f of x, here's g of x. So think about what we're going to do for the product. The quotient function, and think about the restriction here. And then here, with the product function, what is the value when x equals 2? So give that a shot. Okay, so hopefully you saw that here I am just multiplying f of x times g of x. They're two binomials. I'm going to do FOIL. I get 2x squared plus 4x minus 3x minus 6, or 2x squared plus 4x minus, plus 1x if I combine those. minus 6. And so this is f times g of x is that. And now, for the quotient function, f over g of x is going to look like 2x minus 3 over x plus 2. And hopefully you saw x cannot equal negative 2. That makes sense. That's my NPV for this denominator. Oop, negative 2. And now here, I'm just going to use this function and determine what is the value when I put 2 in for x. So f times g of 2 is going to be 2x squared, except x is 2, plus 1x, except x is 2 again, take away 6. And so I get 2 times 4 is 8, plus 2 minus 6 is 10 minus 6, which is 4. So then the f times g of 2 equals 4. All right. Here, another problem in which we're given two functions. So f of x is a linear function, g of x is a radical function, and we're going to look at the domain and range for f of x and g of x, and then evaluate this guy and sketch the graph. So, for f of x, the domain, it's just a linear function. So x can be anything. The range, y can also be anything. Remember, this is just a line. However, for g of x, which is a radical function, which we're going to be studying a little bit later, but from 20-1, you know about radicals, and we know the restriction on here that this x has to be 2 or greater. If it's less than that, I'm going to end up with a negative value in the radical, and I can't take that root. That root does not exist. So the domain is that x must be greater than or equal to 2. And x is an element of the real numbers. So that first one, f of x, let's just sketch that over here. So f of x is x minus 3, so it goes through at minus 3. The slope is 1. So I'm just going to draw that line on here like that. And that is f of x. And g of x is the square root of x minus 2. So let me put that in my calculator, because we're not that familiar with those, and see what that looks like. And you end up with a graph that looks something like this. And that's g of x. And I've just drawn it there in blue. And, all right. So continuing with this, f times g of x is going to look like x minus 3 times the root of x minus 2. And so what I want to do is just enter this into my calculator and see what does it look like. And sometimes these functions look a little bit weird, and so we'll have a look at that. And hopefully what you can see when you graph it is the domain. So remember, the domain is common to the two. So that means the overlap, right? Where do they overlap? F of x, x can be anything, okay? Over here, g of x, x has to be greater than or equal to 2. So the common domain would be where they overlap. X has to be greater than or equal to 2. Because I can't take out here, like a value, there's no blue function over here. So I can't take that and times it by the value on f of x. Just makes sense that if the graph only exists starting here, that's a value I can times by f of x in red. And so what you see on your calculator looks something kind of like this. And so that's f times g of x. And there's the domain. Remember, this isn't a quotient function, so I don't have to worry about the non-permissible values. And then the range I get from the graph. And so I can see that this point down here, I'm going to have to find that minimum using the calculator. So where was that? When I found it, I think it was negative 0.38 or thereabouts. So y is greater than or equal to negative 0.38. And y is an element of the real numbers. So there we have it. All right. Here's another one. And we're looking at a quotient function this time. And this is the last problem in this lesson before you can start on the assignment. So first off, f of x is the root of x. So if I graph that in my calculator, the function there looks something like this. And so I know that the domain for f of x is x must be greater than or equal to 0. And that makes sense. I can't put a negative value in here. The smallest I can put in is 0. The range that I see from my graph is that y is also greater than or equal to 0. G of x is a quadratic function. So let's do that one maybe in green. Just a little sketch over here. G of x, x minus 3 squared. Well, it's going to look something like that. Domain for a quadratic, well, we already know that from before. It's everything. And the range, this one is greater than or equal to 0 as well. My lowest point, that minimum is right there at 0. So now for this, f over g of x, I put this in my calculator as the square root of x divided by, and you want to use brackets here around this in the calculator, x minus 3 squared, like that. And where are we? What does our graph look like? So if I graph that guy, I end up with a vertical asymptote. Again, we can see x cannot equal 3, right? If I put 3 in here, then I'd be in trouble. I'd be dividing by 0. Let me get a graph that looks not quite like that. Oops. Get rid of this bit here. Something like that. All right, so there's our sketch. The domain and range of our of our function. Remember, the domain is what's common, and including our NPV. So x such that x cannot equal 3. X must also be greater than 0. There we are. And the range, again, you get from the graph, and it is y is greater than 0 as well. All right, here we have it.